This sound is a familiar one. A vibration on your phone lets you know that you have a new text or notification. But maybe you don't know that this effect is one of the most basic forms of a field called haptics. Haptics refers to any interaction involving touch, or specifically touch feedback. Think a laser tag, how a direct hit allows you to feel vibrations on the gear that you're wearing, or a PlayStation controller that rumbles when an object impacts an on-screen character. But let's start with your phone. You feel different vibrations in your pocket that let you know someone's calling or texting. You can even set up customized vibration alerts for specific contacts. But what if these vibrations could communicate more than that? What if the vibrations could be a specific way of reminding you to pick up milk as you drive home? What if you couldn't see at all, and these vibrations could help guide you through obstacles in a hallway? What if touch was the only sense you had? The haptics field is wide open, and researchers are finding more and more ways to communicate through touch. Jan Vissel is one such researcher. Jan is a faculty member at the University of California. At his Retouch lab in Santa Barbara, he's currently creating electronics that mirror one of our most important senses, touch. Here's his more official definition of haptics.
So haptic engineering refers to engineering systems that address the senses of touch and movement in the body. Together we refer to those as haptics, or that otherwise mimic its capabilities, that, in other words, allow engineering systems, often electronic systems, to either provide touch feedback that's similar to what we experience when we interact with the world, and by extension, afford interactions that are similar to those that we experience in the world, or perhaps new ones that we imagine.
The haptics field, however, is getting far more complex than a simple text alert. For a robot to open a door, pick up or crack an egg, tasks that we take for granted, a sophisticated robotic system will need to interact with a delicate sense of touch. Jan and his lab are currently developing haptic technologies, specifically electromagnetic stimulation devices, that are designed to mirror the mechanical and sensing capabilities of the largest sensory organ in the body, our skin.
We design robotic systems for touch interaction that are intended to both capture touch information from the world as kind of adeptly as biological systems are able to do, and to facilitate rich interactions. It's a pretty interdisciplinary context that we work in. We do a mix of basic studies in science and foundational engineering research, designing the enabling technologies that will allow us to, say, provide touch feedback that might mimic the experience of, touching fabrics in a fabric store and discriminating easily thousands of fabrics, or interacting with objects around us, and we investigate new applications of these technologies.
Jan is currently building miniature electromagnetic actuators that are soft and deformable, like tissues in the human body, and they yield incredibly fast responses on the order of 1 millisecond, matching the precision of the human sense of touch. This kind of component could provide the quick and complicated feedback required for virtual reality, soft robotics, and wearable computing. Advanced, almost science fiction applications. The type you see in movies like Ready Player One, where a kid in a full body suit receives all kinds of complex sensory feedback as he interacts with a virtual world. In this episode, we'll first look at some of these flashier haptics applications. A real-life full body suit that can help its wearers interact with a virtual world. Then, we'll meet 2 more engineers who are creating new haptic technologies, much smaller than a whole suit, designed to use touch to help people in the real world right here and right now. So, here's an idea. Haptics. A technology not on the market yet, the HoloSuit from Kayatech, allows you to fully enter virtual reality, from head to toe. The suit, which includes a pair of pants with feet extensions and a jacket with a head extension, has 36 total sensors, 9 haptic feedback devices, and 6 input buttons. The black suit might not look like much in the real world. It's a bit baggy. Almost looks like what you'd wear to the track on a cold day. But even though it lacks the kind of sleekness you might expect from movies, it works. The HoloSuit covers and virtualizes a wearer's entire body. And the idea is that users, with the help of the feedback from sensors and haptics, can train their bodies through specific exercises that require physical muscle memory. HoloSuit captures your entire body motion, including your fingers, your head, and your feet, and it can transfer the motions to a robot or avatar in real time. A valuable application for, say, emergency responders who may not be able to operate safely in the physical environment.
There are so many simulators which are extremely expensive, physical simulators. So now all those simulators can be replaced by this HoloSuit because you enter the virtual world and now you can manipulate in the virtual world.
Here's Harsha Kakeri, the CEO of HoloSuit. We talked to him from India. Harsha was a robotics software engineer for Microsoft for years. The suit, currently on Kickstarter, is a passion project for Harsha. He was inspired while doing yoga and having some fundamental issues with his Fitbit.
So I was a yoga, so I did like 1.5 hours of yoga, did a headstand, everything for 1.5 hours. And then it said, oh, you burnt 3 calories. So basically I was like, okay, this is completely not correct because all these trackers are essentially looking, hallucinating data. They're just looking at one point. They can't distinguish between a headstand and a leg stand.
Harsha wanted to create a technology that had a better understanding of an individual's entire body movements, an actual level of balance in, say, a side plank. So he created the HoloSuit, one that accurately measures the whole body and uses that data to support interactions in the real and virtual world.
It will track all your body motion. So you will be able to point to objects either in the real world or in the virtual world. You'll be able to touch them and feel them through the haptic feedback which is distributed throughout the suit.
The 9 haptic feedback points, 4 on the jacket, 1 on each glove, and 3 on the pants, allow someone to feel objects that can't be felt in the physical environment. Each of the haptic exciters provides specific sets of feedback. So in the virtual world, maybe you're designing a product, one you can see in your wearable display headset. Designers from various physical locations can collaborate in the same virtual space and inspect the same object, like a car part. Using the HoloSuit interface, for example, a person can change the shape of the car or the color, and that change can be seen by everyone in the virtual space. Each person virtually walking around the car is instantly visible to the rest, and they can point at, touch, and move 3D objects. They even activate the haptics and create a buzz by virtually bumping into each other. And the response has been great so far, says Harsha.
SlashGear is calling us the Ready Player One suit. So all around the world, I mean, like we have customers in Japan, Russia, in Spain, in Italy, in France. So UK, USA, like everywhere, like people are really, really excited about the potential of this technology.
Beyond being a Ready Player One suit for the virtual world, however, the creators of the HoloSuit hope to help in the real world as well, providing wearers with a kind of new and improved full-body Fitbit, measuring endless data points from your whole body. Someone taking a yoga class with Harsha, for example, could see a model of how their body is moving, exactly how their arms are twisting and their legs are engaged, and all that information could be stored in the cloud. It can act potentially as its own kind of yoga instructor, with the buzzes encouraging you to adjust your body to the correct posture.
It will automatically detect the pose that you're trying to do. And then, like, for example, if you're doing a warrior pose, it will detect that using machine learning, and it will kind of start saying, okay, like, looks like you're trying to do this warrior pose, and this is how you can do it better. And slowly kind of starts improving it. So these are all like things which we are incorporating to make the life of people better.
A baseball player or golfer can similarly receive sensor and haptic-driven feedback about how their swings compare to an ideal swing. Haptic exciters closest to that discrepancy will activate, allowing a user to work towards a model motion. Embedded sensors capture the body motions and provide data wirelessly through either Wi-Fi or Bluetooth to a VR setup where someone can see the model and perform analysis. One of the more promising and surprising applications, perhaps, is how the suit may be able to help in the medical field, recognizing through movement if a wearer is showing subtle signs of tremors related to Parkinson's disease. Similarly, a person undergoing physical therapy can have his or her body movements tracked and analyzed to show personal progress. Harsha even sees the suit being able to someday retrain one's brain, measuring and categorizing patients' movements and brain responsiveness after they undergo brain surgery. Although very much a work in progress, the virtualization of the body through the HoloSuit can potentially gamify rehabilitation and exploit the plasticity of the brain to speed up recovery.
First, we will focus on quantification of like, okay, so objectively, how much is the improvement? then we are actually looking at actively providing them this virtual reality based and even like normal like 2D video feed game type of training. So by kind of helping these patients regain their full body motion, we kind of make them like integral part of the society. We give them their dignity back, but more importantly we also give a lot of joy for their family.
So when we think haptics, perhaps we go right to Ready Player One. But the field is wide open, leading to all kinds of opportunities if someone wants to tinker with the technology. Tommy Sullivan's always tinkering and coming up with ideas. Like that time he wanted to help his wife, a photographer, take pictures of wildlife.
I also built a device last year that takes pictures of hummingbirds that our hummingbird feeder automatically when it hears the wing flaps of a hummingbird.
This is Tommy. He's got plenty of other ideas. He's an electronics and software engineer and teaches microprocessor technology at a local community college in western Massachusetts. It was after school let out one summer when Tommy came up with a new idea, one he thought of when he met a blind woman while on vacation in Maine.
We were in Maine and we met a couple when we were out at a restaurant. There was a show going on, and I offered my seat to the woman because I could see she had a seeing eye dog, and they were going to make them stand. It was standing room only at that point, so I offered her up my seat. So we got talking to them after, and found out that she had been blind since their, I think it was their first child was born. So I couldn't stop thinking about it after I left Maine. I assume a lot of times that devices have already been built to help people, that I'm not going to come up with some magic new idea.
A short time later, however, a friend of Tommy's had a freak accident and lost sight in his right eye.
And he was out of work for quite a while. He's never going to be able to see out of it again, but he said the most unnerving thing is not knowing what's on my right side, because he said, you lose so much of your peripheral vision. I couldn't stand hearing him say that. So I built him a device that measured distance and hangs on the right side of his glasses. And it provides haptic feedback through a little vibrating motor to tell him if an object is closer to him.
That device hanging from the right side of the glasses was an infrared laser that could sense objects within a meter or so. As soon as Tommy finished the device for his friend's right eye, he thought of the woman he met in Maine. He decided to move the haptic vibrations and the sensor to the center, above the nose instead of on the right side, to help someone who's completely visually impaired. The new and improved glasses still use the infrared laser. A microcomputer integrated into the glasses reads the distance and converts the information into vibrations back to the user. Vibration in the haptic motor increases at an inverse proportion to its distance from an object. In other words, the further away the object is, the lighter the vibrations.
Because it's such a precise sensor, it's not like some of the acoustic sensors that send out a pulse that is sort of telling you if some big object is nearby. These are very, very specific, up to 2 meters. They have a very small dot size. So the idea is you can move your head like you're a radar antenna. So therefore, if you're moving your head and sweeping it a little bit, will you start to notice that or form kind of a mental image from the vibrations of what's in front of you?
And they look like glasses. For a quick second, they almost seem like futuristic sunglasses that a pop star might wear as part of a stage costume. The glow coming from within the frames, however, isn't a fashion choice. The glasses are basically a printed circuit board. Tommy designed them himself, taking a printed circuit board and cutting and grinding it down to the shape of glasses, and then bolting the prototyping board onto frames that Tommy 3D printed. And right on the bridge of the glasses is a square-shaped laser sensor. Tommy also laid out all the steps in full detail on Instructables.com, so anyone can make them.
I would say they're probably not the most comfortable glasses in the world, but they look like somebody's sunglasses would be.
Tommy's been through 3 prototypes, testing them indoors, in office buildings and inside his own house. And people who've tried them out are impressed.
Get a lot of oohs and ahs when they first put it on, because they're usually looking at me when they put the glasses on, and so they sense a big vibration. Then they turn their heads out towards, say, an office space or a hallway, and it goes away, and the next thing you know, they're saying, wait a minute, and they're moving their head all around trying to find different things and sense the distances. The people who have tried it can sense a hallway, and you can tell that the walls are tapering away because you get this tapered vibration as you run your eyes from far left towards center. You can sense the vibration drop off. So you can say, okay, there's a wall on this side, and sense one on the other side, and look down, see the floor, look down and see the ceiling. And then when you look straight ahead, the vibration stops. There must be, nothing for 2 meters in front of you at least. Again, because the beam is so small, the hope is that the brain will start to use that to form at least a rough image of what's in front of the wearer.
For blind people, a cane works for lower level objects, but not the higher obstacles, like a cabinet door left open. Even Tommy's had first-hand experience with this. As a teenager, Tommy was working with welders and burned his eyes, causing them to be patched and leaving him without sight for the day.
For me, that's my only experience with being blind, and I was only blind for, part of a day. But I hated not knowing if something was going to hit me in the face. And I don't know if people that lose their vision, if they or born without it, feel the same way. But it actually bothered me very much to know that I don't know if something's about to hit me in the face. And again, with the cane, you can feel low, but with the glasses, you would know if something's up high.
Tommy's still working on new adjustments to the glasses. Currently, for example, the glasses only work inside, away from the sunlight that often saturates the sensor. He's also experimenting with replacing the vibration with a beep. The process doesn't consume too much of his time at the moment, but if he has a few minutes, he'll solder and grind and 3D print and put things together.
Again, it's just a prototype, just a fun little project I'm doing on the side, but it might be possible to add Lidar sensors, these little laser sensors, I guess, to the sides of the glasses too, and maybe have the glasses have points of contact for the side of your head. So maybe you can get feedback in 3 positions. I don't think you'd want it to be too many, but maybe these glasses could measure forward and on the left and on the right and give you feedback for all of them. So there may be another prototype coming where we try that.
In the meantime, he's testing the glasses on a variety of subjects, including a woman who has been blind since she was a teenager. As for the woman from Maine who inspired the technology, Tommy hasn't been able to reach her yet, but he hopes to get her a pair of the glasses soon. Deaf and blind people have been using the sense of touch for communication for a long time. One example is the Tadoma method, which involves significant, long-term training. The deaf and blind person places his or her hand on the tutor's lips and jawline, interpreting words and speech based on the reader's subtle movements, airflow, mouth shape, muscle tension, vocal cord vibrations. That's all being picked up by the deaf person's hand, using the facial movements as clear cues for words. Anne Sullivan famously used a version of the Tadoma method, sometimes referred to as tactile lip reading, to communicate with Helen Keller, who became deaf and blind by age 6. Helen Keller would place her hands on her teacher's jaw and lips while also feeling the vibration of the vocal cords.
Being inspired by the Tadoma method, we began to develop synthetic approximations of how Tadoma works. We built a display that had an artificial face and movements of the jaw and lips. So we then wanted to develop sensory aids that would allow people to communicate at a distance, because all these methods require person-to-person contact.
This is Charlotte Reed, a professor and researcher at MIT. Along with her colleagues, including Hong Tan, a professor of electrical and computer engineering at Purdue University, the team set out to create some buzz, specifically a way of receiving messages via vibrations through the skin on the forearm. Hong stressed the importance of detecting environmental background noise and more.
People who are deaf have the need to know if they left the faucet on accidentally or the front doorbell is ringing. There are a lot of scenarios in life where I may not be blind or deaf, but I'm situationally blind or deaf, or I just shouldn't be reading or listening to things. So, for example, if I'm driving, it's better that I'm not looking at my phone for text messages, but it might be something like I have a little reminder that says pick up milk on the way, and it'll be nice if I just felt something on my arm as I'm driving and I get the task accomplished.
Hong is the founder and director of Purdue's Haptic Interface Research Laboratory. She said that while the research lends itself to being used by hearing impaired and visually impaired users, the study is also being looked at for broader applications. The team, in fact, is collaborating with Facebook through the company's sponsored academic research agreement. Facebook is interested in developing new platforms for communication, and that includes haptics. So how does Hong and Charlotte's technology work? Think of it as a Tadoma technology, but instead of interpreting motions of the face, users can receive feedback from a vibrating sleeve worn on the arm. When you speak any language, each word is, of course, made of separate sounds. The different sound units are called phonemes. In English, there are 24 consonant phonemes and 15 vowel phonemes. Charlotte and Hong created a wearable system that encodes each of these particular sounds into sensations. So, if you feel a series of signals that encode ha, o, and o, that's me saying hello. Now, imagine you're wearing a sleeve on your arm. Within that sleeve, there are 4 rows of 6 vibrators, or actuators, that go from your elbow to your wrist. So there are 24 total actuators that create tiny vibration sensations on your skin that feel like the vibrations from a cell phone. What they've created is a system that can use those sensations to encode all the sounds of speech in patterns, and they've trained people to receive and understand those speech patterns.
For example, some sounds might be presented near the wrist, and other sounds we code near the elbow, and the vibrations move in a pattern across the array in different directions, just to get a better idea of what these signals like. And they're producing vibrations on the skin that you can feel, and so you're asked to associate each pattern with a different sound of English, one of the phonemes of English. And in our tests, we first tested, we wanted to see if people could identify the phonemes, the full set of English phonemes, because in previous studies with earlier generation tactile aids, this had not been very successful. Performance had not been very good through the tactile sense alone. And so we wanted to see what we could do with our new system. And we found that people were capable of, within an hour or two, learning to identify the individual phonemes at an accuracy. Most people could achieve an accuracy of 90% correct or better.
The challenge for Hong and Charlotte was to create a rich set of signals that people can easily differentiate. And the other challenge was to help people learn quickly. The students or volunteers come into the lab and are trained for about 10 minutes a day for 2 weeks at a time, and only a few patterns at a time. Slowly, a few phonemes become a few words, and a few words become a sentence. Through their training, they give their subjects feedback. They tell them how they're doing, and they test them on the sound recognition.
So they do this for 2 weeks straight. And so it's 10 minutes a day, 10 days, 100 minutes. Our best people can get up to recognizing 100 words of English words made up of all the 39 phonemes of English.
Charlotte and Hong's team used the system to train people to learn from around 100 to now over 500 words. They see unlimited potential for this technology and have demonstrated that people can learn the main aspect of the system within hours, instead of weeks or months or years of training. That's significant. It means that people can get back up to speed with a small, usable vocabulary right away. And some trainees are even more eager than the trainers themselves. Hong tells the story of one excited student who keeps coming back for more training.
She just gets it and she wants to come back to get more and more. And she's thinking of so many other applications because she's passionate about working with kids with special needs. So she's now thinking if this could be something really useful for kids who are autistic to get their attention or to deliver information to them through a different way, like a game.
Charlotte mentions another application. The system can provide some encouragement, sending people the kinds of approving, reassuring signals that aren't always easy to communicate in real life.
Maybe presenting a reassuring pat on the arm or, a warning signal or things like this that convey emotions through the tactile sense is another possible application.
Hong sees the device being used for the deaf and blind and those with sensory disabilities, but also as a communication method for the general public.
If we only make a tool for people with sensory deficits, I sort of feel like the business model is not there. Nobody's going to make a lot of money out of it, and therefore we can't really help these people over the long term. If we can make this just a natural alternative way of communicating, then deaf people will benefit and deaf blind people will benefit.
Hong compares haptics technology to that of the ramp, a design feature first built and mandated to accommodate those in wheelchairs. Today, however, ramps are being used by everybody, including parents pushing baby strollers. Haptics, similarly, can be a very convenient, nonverbal way to send and receive alerts.
So that's kind of my dream, to do this for the general public.
There are plenty of ways to realize this dream. Perhaps it's no wonder that a social giant like Facebook has a stake in haptics technology. Imagine a blind marathon runner, or a first responder who can't navigate around obstacles in a given environment. What if vibrations on the arm could send a signal that says go right or go left? What if a specific vibration pattern could keep you undistracted at the wheel? So maybe wearing a full body suit like the kind seen in Ready Player One seems a bit too sci-fi, even a bit silly. But the applications for touch-based technology are anything but. And as we've seen in this episode, haptic technology can be made to fit the entire body, or just take up a small place on the forearm or the bridge of your nose. And the flashy consumer appeal of virtual reality and augmented reality, the popularity of the Oculus Rift, may be just what's needed to popularize haptic technology, to make components cheaper, to help fund more specialized medical applications. Tommy Sullivan, creator of the Radar glasses, envisions a way that touch-based feedback could someday help his mother, someone who's been paralyzed for the last 22 years.
She's confined to a bed, and I've wondered about these technologies because I think that both helping people that are visually impaired, is a good thing, but I'm wondering what some of this feedback technology is going to do for people that are somehow physically unable to do anything. They're not going to be able to experience the world. And since virtual reality's come out, I've thought about my mother, thinking people like my mom, they're never going to be able to go visit a castle in Ireland or feel what it's like to be on a modern roller coaster. Maybe some of these technologies and haptic feedback will provide a way for people in that position to experience more of the world. So I wonder about all that while I was building it and just thinking at where it might go years from now.
A world that, right now, we can only imagine. This has been an episode of Here's an Idea. I'm Billy Hurley. To learn more about the technologies featured in this episode, you can go to techbriefs.com/podcast, where you can also subscribe to the new Here's an Idea Full Picture newsletter. The Full Picture gives you photos, facts, and follow-ups related to the haptics technologies you've just heard about. We want to hear from you. Give us a review on Apple Podcasts and send feedback to podcasts@techbriefs.com.